Alright, so first thing. Alright, so first thing what we are going to do is we're going to start with our transformations. If you would look at your...
Man, I forgot.
Yes, ma'am.
I'm sorry.
Alright, so if we would, on the front cover, we're talking about transformations in this unit. So we're going to fill in the blanks for what they have there. So the first thing says transformations. Changes a figure into another figure. The new figure is called an image. We kind of discussed that yesterday. You guys were doing your Desmos. So, putting it on the front of your cover. So that's going to be our biggest thing, is that what we are learning about is how transformations are going to be changing one figure into another figure. Today, we are going to be discussing the translations. Now, based off what we discussed yesterday in Desmos, what was our translation? What does it mean to translate something? To make it move. What do you mean? You need more about that.
To move, to slide it or rotate it.
Google Translate.
Okay, to change its location.
Or rotation.
So remember, but is it translate or rotation?
No.
No. So rotation is going to be another part. So when we translate something, we're going to slide it. Remember, on Desmos, the one part that we liked was with that orange line. It showed how it's going in a straight line. So open up your foldable to this next page.
Oh, I can help it. I can help it.
And we're going to fill out right here. The first one we're going to say translation.
Alright, so that's for you.
Give
Give him a lunch.
Here, I got some paper.
That's a waste of hand sanitizer.
Yeah.
Yeah, I gotta write up
Be
for that.
quiet,
Remember
Alex.
that? I gotta write up for that. Remember that?
Or pouring out. Someone yes, I do remember that.
That's a waste. You said it was not a waste.
I don't want on my hand.
Yeah, you're playing it out.
Oh, I get to point her out.
I know, but you're not focusing, you're not able to focus right now.
No, you should get a write up. Unless you don't get a write up.
Parker. Parker. You're not in charge right now. Alright. Turning to this next page.
That's why I have my hoodie on.
Have your planner on, Marty. I'm moving you. You're interrupting me as I'm trying to teach right now. Have your planner out? Zach, have yours. Okay, this first one, we have translation. To translate a figure, we're going to fill in the blanks. We're going to say you slide to a new location on the plane. All points in the figure move the same distance and direction. That's going to be one of the key points that we're going to work on today. Today we are going to do multiple translations. Mainly we're going to work on 2 translations. But each time it's going to be straight line. Okay? Translating a figure in the coordinate plane, we are going to look at that in just a second. We'll look at here. So here was a couple of our examples. We did a translation where we have a figure, and when we translate it, remember our biggest thing is it's moving from one location to another location. We did not change the orientation. We did not turn it. We did not change its size. We did not change its shape. It just slipped from one area to the next. Same thing with this. Even if I change the degrees and I plate it, you're going to notice each one of the points is following a certain one.
Yeah.
But with this, should have made it go that much.
What?
But each time it is changing. So let's look at this part. I think this is what we're going to need. Pretty simple on this. First one, it says, tell one of the blue figure is a translation of the red figure. So is the blue one a translation of the red one. Red one's where we started at. So, what do you think on this number one? It's an upside down trapezoid.
Yep.
Did the blue one translate from the red one?
Duh.
Yeah, it did.
You flipped me off. Yeah, either way now.
There you go, folks. Why do you sit here and then you want to be facing up? Go ahead and have a seat. Because now your back will be turned and you will be facing that board. Go ahead and have a seat, please. Okay, this one,
It's my last name's not intro.
we are.
You're distracting my learning.
Those were 3D shapes.
Guys, focusing on here. We are saying yes, and the reason is each one of the vertices, when we're working with our 2D shapes, we're going to call them vertices. That's our corners. Each one of our vertices move the same direction and the same length. So the distance was the same on all of them. So this one was a yes. On B, why is it not a translation? Braden?
It's not the same shape.
It's not. Well, it's the same shape.
It rotated and
Oh, Zachary, you're interrupted. Hold on. So why is it not? It's the same shape. They're both rectangles. Sierra, focusing up here, please.
My friend?
Avery?
Darkness.
Yeah, that's
Because, say that again.
because the red one's up and down and the blue one's
All right, so this one, it's probably more of a. Parker. If I'm talking again, I am sending you to the office.
Office with
Yeah. If you don't want to learn here, that's fine. I'll send you out. But now you're stopping. Everyone else is learning.
darkness.
Okay. So we will have a rotation. This one is a rotation. Yes.
Darkness.
All right. So let's have you guys look at the next two. So we said this one was definitely a no. Number 1 and 2. Trying to decide, is one a translation?
Yes.
Troy?
Yes.
Why is it translation? Okay, so it looks like from red to blue.
Bigger than the other.
Good. So now let's talk about that. It looks like each one of these points just moved to the right. However, you said
It's
what?
bigger one. The blue one's bigger than the red one.
Yeah, the blue one-
Yeah,
that's the red one's behind it.
That's what I was
See, you're looking at 3, but we're looking at these. Remember,
It's not an illusion.
that's actually a good idea. Hold on. That's a good idea. But remember, we're talking about 2D objects, and so we're on a plane. A plane is not 3D, so the red one cannot be behind it. The red one, we're on a flat plane, so they're side by side. So I totally see what you're saying, though. Like, if I looked at this 3-dimensional, it could look like they're stacked, so then maybe they are the same size. But when we're working with 2D shapes, they're on the same plate, so they would be different sizes. So on this one, and Molly, I'll come to you in just a second. No, the size changed. The blue one got bigger. All right, now what was your question?
My question?
Yeah.
Okay, so I thought that if you had one of the points and it was on the same slope, that it was still the right, like it was still like right. Because like, what if you take the left corner and it's still on the same slope as the other left corner?
Okay, so what you're saying is why would this not just be a translation?
Yeah.
Okay, this could be a translation. Like it could have slid, but it also did a dilation where it's going to make it bigger. So right now we're just trying to identify is it only a translation. But you're right. Like if you guys look at this, you could say, hey, this one slid from here to here, this one there to there, here, and there. They could have all slid the same distance, but then they also got blown up. So we're going to say that's our dilation.
Can I do
So it would be a translation and a dilation. Can we have more than one transformation? Absolutely. We can do a rotation, reflection, and a translation all at once. It's just, we're checking right now, is this just a translation? We're looking for just one. All right, so how about number 2, Zach?
Yes.
Good. This one is a translation. They're the same size.
Look, see, it's
They all, it makes it 3D when we take 2D shapes and
Yeah,
connect them.
dummy.
So this one
That's confusing.
is a yes. Now, if that was our homework today, which is actually part of it, it'd be pretty simple. We're going to take it just to another little point where we're going to put them on a coordinate plane. This is in your foldable. So if you're looking at your foldable, it's on the orange on the inside. We're going to look at the two ways to change this. We're going to translate the red triangle 3 units right and 3 units down. Okay, my first question is, if we go left or right, if I tell you we're going to translate left or right, left or right, which axis is that going to affect? Is that going to affect my x or my y? My x, right? X coordinate's the one that tells me how far left and right we go. So when I go,
She's trying to learn.
when we do the left and right, we're using our x-axis. So if I go left, that means I'm taking units away. I'm going to be subtracting. If we go to the right, we're going to be adding units. So if we move left or right, we're messing with the x-axis and our x coordinate. When we're on the y-axis, that's when we're going up or down. If we're going up, we're adding. If we're going down, we're subtracting. And that's affecting our y coordinate. Okay, please focus up here. The reason this is important is because this is going to be describing what's happening. So, in your notebook, if you want to take these notes, that'd be good. But let's go ahead and do this one. This is the example we have. It told us to move my red triangle 3 units right, 3 units down. The first method is going to be the preferred method for most people. It's the easiest. What they'll do is 3 units right. So let's do this. 3 units right. So I'm going to look at every single one of my vertices, and I'm going to move right 3 units. So I take my B point, and I'm going to go over 3 units. But then it also told me that I need to go 3 units down. So then I will go 1, 2, 3. That gives me my new point. And that's really all there is to it. On method 1, I just have to go to every single vertice and follow that. So I'm going to go to vertex A, 3 over, 1, 2, 3. I went over 3. I need to go down 3. 1, 2, 3. Which makes my new point here. We go ahead and do it on the third vertice for C. 1, 2, 3. 1, 2, 3. And now that we have our 3 vertices, they all stay the same, and I can connect them. That is all that it takes to do method 1. Follow the instructions for each one of the vertices. Okay, I'm done. Come on. Get your stuff on. Get your stuff. I'm done having you mess around. Please get your stuff. Or I'll just go to the office and ask them how you come. It's your choice. You can either come and go to another room, or I'll go to the office.
I'll wait for someone.
Okay. I know. Alright, so let's finish up with method 2 now. Now, method 2. Method 2 is not as difficult, and it's not real complicated. The reason I would say we use method 2 is I use method 1 when the points are even and simple movement. But if I'm going to move like a fraction, or if I'm going to move a decimal, and I'm not moving full units, I would use method 2. Method 2, we are going to use addition subtraction. Here's how we do it. I'm going to take A. I got to find the original coordinates of A, which are 2, 1. Oops, negative 2, 1. So A's original point was negative 2, 1. What I'm going to be doing is, when I'm adding 3, when they told me to move to the right 3 units, that's why we took these notes right here. If I move right, it's affecting my x-axis. So I would rewrite this and say my x-coordinate was negative 2. I'm going to move 3 to the right, which means I'm just going to say plus 3. For my y-coordinate, the original coordinate was 1. And they told me to go down 3 units. Going down affects my y-axis, so 1 minus 3. And then all we have to do is simplify. Negative 2 plus 3 would give me what? 1. Negative 2 plus 3 is 1. So my new x-coordinate should be 1. My y-coordinate was 1, and we subtracted 3. So it should be, what's 1 minus 3?
Huh?
1 minus 3.
Negative 2.
So my y-coordinate is negative 2. Well, let's check and see if that turned out right. I'm saying A should now be at 1, negative 2. We go to our point, 1 over, 2 down. There was our A. So like I said, method 1 works really well if they're giving you whole units and we're not going very far away. It's pretty simple. Method 2, we're going to continue looking at it. If the coordinates for 2 was 2, 5. Okay. Coordinates were 2, 5. When I come back in here, here's 2. There was 5. But in the instructions, they told us go right 3. So moving left and right affects our x-coordinate. So we add 3. They said go down 3. So that affects our y-coordinate. So I'm going to minus 3. And then you just solve. 2 plus 3 equals 5. 5 minus 3 is 2. Our point B should be located at 5, 2. And if we check, over 5, 1, 2. We did that one correct. Last one is C. C was originally at 1, 2. So once again, all I'm doing is saying 1, which I don't use for a reason. All I'm doing is saying x was 1, y was 2. They told me to go right 3 and down 3. So I look at my x-coordinate. My x-coordinate is 1 plus 3, which is 4. And the y-coordinate is 2 minus 3, which is negative 1.
I said aim for Troy. You throw it.
To what?
I said aim for Troy. You throw it.
Go tell her why me.
Oh, man.
Hey, and so
All right. Oh, it came all back. Alright, so then I'd have 4 and negative 1. So, these are our two methods. To be honest, for today's work, you will probably use just number one, the first method. You're going to count over. You're probably just going to count over on the coordinate plane because it's easy. Honestly, I would use method 2 when they ask me to move fractions or decimals, or I'm going long distance. If they told me I need to translate 32 points, I don't really want to count 32 over. Instead, I would just add. All right.
Troy's being mean to me.
Troy, don't make me send you out. And then just avoid each other. Focus on getting talk to me. Alright, so here's what we're going to do. I'm going to show one other way how you can do method 2. The vertices of the triangle are at A, -2, -2. So we got to put that in here. So -2, -2. B is at 0, 2. So I'm going to say that was A. 0, 2. 0, 2. That's B. C is at 3, 0. And that's it. Alright, let's zoom in on this. Okay, I'm going to go ahead and connect my dots, my coordinate points. Alright. Now, it tells me what they want me to do is I want to go 1 unit left, 1 unit right. Honestly, nothing else makes you get this out of today's assignment how to do method 1. All you have to do is each vertice. So this is a triangle, which means there's 3 vertices. You're going to move each one of the points. If I follow these instructions, 1 unit left. I'd go left, 2 units up. 1, 2. That's the new point for B. Make sure you label the points. I look at A. 1 unit left, 2 units up. Went over 1, up 2. That's A. I look at C. 1 unit left, 2 units up. C. And there is my triangle. That's all there is to translation. Move, start at a vertice, move left or right.
Do you have to start at A or can you start at any of them?
No, you can start at any one of the vertices. Okay. And you don't have to go in a certain order, you can jump right wherever you want.
What?
No.
I did not hear what you said.
I said only Molly has to start at unit A.
You have your stuff. Alright, now, I really feel like you guys will be able to do method 1 pretty simple. But I want to make sure we understand method 2. We are actually almost done. So, here's what I'm going to show you another way to do this. And I like this way better. For A, -2, -2. Now, when they told me to go left 1 unit, going left 1 unit means that is going to be subtracting 1 for which coordinate? For the x coordinate or my y coordinate? For my x coordinate, because we're moving left. So, I move left. I'm going to subtract 1. I'm going to go 2 units up. Going up and down affects our y-axis. So I'm going to say plus 2. I'm going over this because on your test, you are going to have to use both methods. We're going to ask you to do one method. We're going to ask you to do the second one. Now, once I have this, set up, I'm just going to add up and down. Negative 2 minus 1 is negative 3. Negative 2 plus 2 is 0. That is my new A coordinate. The coordinates for A should be at negative 3, 0. And if we look, we were at negative 3, 0. You do B, same way. B was at 0, 2. Now here's the nice thing. If you take your time and set up the first point, and you make sure you set it up perfect, that you did not mix them up, that you got the X and the Y correct, I can copy my formula. If I did negative 1 plus 2, negative 1 plus 2. And we add. My new B coordinate is 0 minus 1 is negative 1, and 2 plus 2 is 4. My B coordinate is located at negative 1, 4. Same thing for C. C was at 3, 0. And I'm going to say D was at, oh, there wasn't a D.
Behind CD.
Alright, so we follow the same rule. 3 minus 1 is 2, and 0 plus 2 is 2. C's coordinate is at 2, 2. Okay, last thing for you to do, and then I'll talk about your homework, is this is in your foldable. It says translation, it's the pink sheet. So the first thing I want you guys to do is go ahead and plot these points. It said, a landscaper represents a park using a coordinate plane. He draws a square with the vertices A at 1, negative 2, B at 3, negative 2, C at 3, negative 4, and D at 1, negative 4 to represent the location of a new fountain. Okay, if you have yours, is anyone willing to come up and try and graph those? Molly?
I graphed the ones that are okay.
Yep.
Got mine.
Then it'll work.
Wait. Oh,
You have a triangle.
okay, can you scroll up a little bit?
Yeah, that's fine.
Oh, I
Here, do we need to zoom out as well?
There you go.
It'll be what our homework's going to be.
I'm gonna change it to highlighter.
Oh, is it on pilot?
It's right. It's correct.
Yeah, it is. Mommy always
I look at arrows. I look at your.
Okay.
I told her to take it out, but she didn't listen.
Use the pen, mark them, and then put A, B, C, and D by. Okay, so one thing that's important, this is why it's good to see you guys do this. So Molly's getting the points down. She's plotting the points correct, but the one thing I need her to make sure she does is identify the coordinate points. So put A, B, C, D. Now connect the dots. Alright, so that is how you should be doing the first one.
Yeah.
You need to identify which each coordinate point is, because if you don't, we can't tell if it really was a reflection, or if it was rotated, or if it was translated. Okay, it says city officials want to move the fountain 4 units left and 6 units up.
Troy, stop talking, please.
Okay,
No.
Troy, can you come do A? Put A where it goes. Ben, can you do B? Ryan, can you do C? And I need someone to do D. Alright, Ainsley. Doesn't matter.
A goes first, and then A, B, C, D. You know, the alphabet.
Alright.
Come on, princess. Take it out of highlighter, you idiot. Oh. Label it.
Molly's a savage. I'm not a savage.
No, I feel like
Sorry,
this would be
clever
right.
people.
What?
Like, kid.
Okay.
That point. So.
Label your
What,
point.
150?
Huh? Oh yeah, name it. You name it. Be serious. Thank you.
Cool, but it's more than yours. Because I got it like 3 years ago, dummy.
You got 3 years ago.
169.
Do I really have to do all this stuff? Or?
No.
All right.
Nobody else labeled it.
Okay,
You like that.
folks, sit up here. We're almost done. So, here's something that I want to discuss real fast. I am going to. Okay. Now, the thing I was going to point out, we've done this correct. Once we did 1 point though, once Troy did point A, Ben said, do I have to really count up on my next one? Can't I just know that my length was 2, so we just went 2 over? And like when Ainsley did hers, she knew, well, this one has to go here. Yeah. To be honest, yeah, with the translation, if the size did not change, the rotation did not change, everything would stay the same. Yeah. But now you're able to double check your work still. If we double check this, you can look 4 left, 6 up. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Good. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Good. That's how we can double check ourselves. Also, if you're looking at your points, I can look at any one of them and say if A was at 1, -2, and I went left 4 units, remember that affects my X, and I went 6 units up, my one should be 1 minus 4, should be -3, and 4. So A's new coordinates should be -3, 4. -3, 1, 2, 3, 4. That's the connection between the two methods. For today's homework, you may do either method. Okay? Here's what your homework looks like. And it's fairly simple. Especially if you're paying attention today, then you have no problem. And you should get it done in class. Okay. Now, listen. Oh, wait, Troy, have a seat. Listen, because this is changing just a little bit. That's why you shouldn't be working ahead, because you probably did it wrong. For the very beginning, it says, for each figure, describe the location of the blue figure relative to the red figure. Well, these are in black and white. So this is how I've changed this. Instead of blue and black, we are going to be looking at it left to right. So in the first two, you're comparing the left figure to the right one, the translation. When it says, describe the location, this should look just like those examples we did, where you're going to say, move 3 units left, 4 units down. Or right 2 units, up 1 unit. You're going to have to describe. On this one, it is 2 steps. On 6, it is 2 steps. So I need you to tell me, do I move it from the left to the right, the left figure to the right figure? You're going to say how many units in one direction, how many units in the second direction. On 7, 8, 9, 10, 11, and 12, all you're doing is saying yes or no. If you want to put Y or N, I'm okay. But you're just telling me, is it a translation and only a translation? So yes or no. And then on 18 and 19, they're on the side. Read the instructions. They want you to draw the translation. They're telling you how many units to move, and you need to make the new one. Just make sure when you do the translation, it's on every single vertex. Yeah? That is your assignment for tomorrow. You may work.